right, ladies and gentlemen, welcome to the Dale Pro Audio booth. This is my hero, Nikola Tesla, and we're going to talk about not only spectral efficiency, but how Radioactive Designs is going about trying to make the most out of what spectrum we have left. Many of you probably know that wireless microphones have shared spectrum with television stations in the United States since about 1962 when wireless mics were invented, same year I was invented. And ever since then we've had auctions, digital television has been introduced, T-Mobile, Verizon, they've all bought pieces of the spectrum, and we've essentially lost half of the television that we've had since 1962. But yet productions still want the same amount of microphones, comms, and IFBs and in-ears to work on a large-scale event. So how do we go about that? First off, a little quick bit of history. We had the Spectrum auction shortly after DTV energized. This incentive auction had the spectrum from 608 all the way to 698 completely repurposed for cell phones, DirecTV, and T-Mobile was the big winner. And all of the wireless mics had to migrate down below that spectrum. In addition to that, all of the television that was above 600 meg had to migrate down, creating further spectral congestion. In addition to that, on large-scale productions now, lots of comm manufacturers have come out and introduced products in the 1.9 gig DEC band, 902 to 928, and other areas of spectrum. So now we're faced with yet a different type of spectral congestion, not only from the DTV that's moved down and wireless mics in that spectrum, but also the 1.9 DEC band or PCS band congestion, and that's what we're faced with now. The new congestion is the 1.9 gigahertz on large events. I work as a frequency coordinator. I've been working as a frequency coordinator since the World Cup in 1994, and I've coordinated hundreds and hundreds of large events from Super Bowls, Latin Grammys, billboards, Latin billboards, country music awards, and I've seen all of the spectrum up in the DEC 1.9 gig band get increasingly congested. So because of that, I've created an RF band plan, a radio spectrum band plan, so that you can maximize the signal to noise and keep each spectrum as clean as possible. With RF, there are base station transmitters like IFB and in-ears, and there are base station receivers like microphones and comm receivers. The idea is to keep the spectrum as clean as possible, which means that our transmitters will be in one spectrum and our wireless mic receivers will be in a completely different, hopefully quiet spectrum. This is based on current technology that exists today. We have IFBs down in the 72 to 88 meg band, Comtech for example, 174 to 216, that's where the Radioactive Designs wireless receivers and belt pack transmitters operate. And then the rest of the band from 470 to 608 is just something that I created based on existing products. 470 to maybe 500 could be wireless mic receivers. 512 to 555 might be base station transmitters like in-ears and IFB. And then the upper edge of the band could be wireless microphones. We also have a couple of bands that I myself and my partner Jeff Shearing and Rad and Henry Cohen, our other partner, went to the FCC on behalf of the broadcast and production communities to ask them to provide us with additional spectrum that we didn't have before to make up with these auctions. Part of that band is 614 to 616. That's a new addition that we've been given. 652 to 663 is a duplex guard band, very empty, and most manufacturers are fabricating product up in that band now, including Radioactive Designs. And the 902 to 928, it's not really something you could coordinate, but you'll find coach comm, client communications, and things like that in that band. 941 to 960, that's a brand new band that we petitioned the FCC several years ago, and they gave to us so that we have somewhere to go to make up for all the spectrum we lost. 1.4 gig, that's coordinated by the Aeronautics Division. 1.9 is where all the current congestion is now, from DEC to like Bolero systems, Free Speak systems. Even Telex has a 1.9 gig DEC communication system. So most of the new communications on the market now are up in the DEC band. As a coordinator, I get onto a large event and I can't put anyone else in that DEC band. It's already overcrowded, it's congested, I can't really coordinate it, so we need a different place to go. For communications, life safety, backstage communications. And of course, 2.4 gig, but that's Wi-Fi, and it hardly ever works. So the owners of RAD have all been coordinators or operators for the last 36 years. We saw this hole in the industry where the day would soon approach where you'd not be able to operate any more wireless communications. And again, on a Cirque du Soleil show, these are life safety. SpaceX and space launch vehicles, life safety. Nuclear power plants, life safety. Broadcasts, live broadcasts, can't lose communications. We created a very narrow band module. In fact, our primary goal with RAD was spectral efficiency. That was the number one goal. How could we pack more wireless communication systems into a band than anyone else in the world, anyone in the market? We went way back to old technology from the 1920s. This is amplitude modulation because it's extremely narrow band, and we're down in the VHF spectrum, which hardly anybody uses. Terribly unused band. So those are the two things that make us the most spectrally efficient unit currently available. This is just a look at what the narrow band footprint of a RAD looks like compared to any other digital or FM system. Usually about over 200 kilohertz is the occupied bandwidth of a digital microphone or a digital comm. We take up 20 kilohertz. We take up 1/10 of that spectrum. So we're quite different from a lot of the 1.9 gig DECT equipment. As a coordinator at a large event, you have to be able to tune frequencies like a car radio. We're able to tune around to any frequency. We have the widest band from 470 to 663 on the base station, 174 to 216 on the belt packs. All the packs transmit in narrow band, occupying only 20 kilohertz. There is a round trip side tone so that if you hear yourself, you know that everyone else heard you as well. In other words, the pack transmits to the base and the base transmits back out to you. So if you hear yourself, that's a life safety concern. You'll know everyone else heard you. We're so spectrally efficient that we could fit 60 belt packs in one empty TV channel. That's more than any other system on the market. WiMAS, digital, low power mode, high density, whatever you want to call it. We're able to get more packs using narrow band technology than anyone else. Because we went down to VHF, we clear up UHF spectrum for microphones, IFBs, and other devices. And this is a big one for setup. In true broadcast fashion, one transmit antenna and one receiver antenna supplies the RF for an unlimited number of belt packs. It's like your car radio. There's only one FM transmitter, but there's a million cars driving around listening to that station. That's how our system works. There is no noding, there is no clogging up of digital nodes. An unlimited number of belt packs could operate off of one set of antennas. Also, because it's narrow band, we get incredible range. Out at Disney World, we have one set of antennas. At Epcot, we're getting half a mile of range out of the belt packs. We've been around for about 10 years, field proven on the largest events in the United States, including multiple Super Bowls, Rose Bowls, NBA All-Stars, been used as mission control for space vehicle launches, lots of nuclear power plants, so it's field proven to be rugged. Very familiar, simple to use back panel, interfaces to just about any comm system. And the belt packs have 4 talk pads, and with the scene change, which is similar to a Q mode on an in-ear monitor pack, you could load up to 20 comm channels on each pack, walking from one zone to another zone to another zone, and 40 talk pads, which is more than any other comm system as well. So as I said, we've already been used in the real world for about 10 years now on all those events you see there, Super Bowls, NBA All-Stars, Major League Baseball, Rose Bowl. I've worked most of those myself, Latin Grammys next month. Country Music Awards next month. Mission Control Wireless, pretty critical when you're launching rockets. Doesn't take a rocket scientist to figure that out. And we're already installed in dozens of sporting venues and stadiums. And again, park-wide at Disney, controlling the entire park with VHF rads. Of course, now they've updated and also purchased Boleros and probably Pliants, but we were park-wide at Disney. And we're announcing the Advanced RF group right now with Dale Pro Audio. And Joel, am I going to swap mics with you? Okay.
Thank you. Hello. Hello, everybody. Wow, that's loud. All right, yeah, here to announce the Dale partnership with, amongst other people, Mr. James Stoffo here, one of the preeminent RF experts in North America, and amongst other RF experts that James knows and has worked with. We're happy to work with you. Anybody who's got any RF issues, potential RF problems, you want to expand your system, you want to start using stereo IEMs, which everyone wants to use now, IFB in stereo. There's so many different things that the RF group can help you with. There's a lot of studio build-outs now going on. There's a lot of personalization of audio that requires RF. It started with curling in the Olympics a few years ago. Everyone wants to hear what everyone is thinking, and that requires way more channels of RF. So let us help you. Talk to us, and we can get your RF situation working as well as it possibly can be.